Okay. I want to show you this other, let's call it algebraic solution to this problem. Okay? So we have the same configuration, the same construction, the same problem. It's this straight triangle of hypotenuse 10 and this intended side of length 6. Okay, this is the side that is intended to be. Okay, the one that we have for sure is the hypotenuse of 10, but remember, this has only intention to be. Okay, so in this algebraic solution we will apply only Pythagoras, the Pythagorean Theorem. Okay, so let's call this side A and this side B. Okay, so I want to highlight that we have three triangles. Do you see the three triangles? This is one, this is another, and this is another. Okay, so far we have three triangles in these constructions, and if we call this side X, let's call it X. Oh my god, since the whole side is 10 and we just call this side X, this side is the whole side but without this, so it's the whole 10 minus the X part. Okay, so this side is X and this side is 10 minus X. Okay, this is A and this is B. So we are going to write the Pythagorean theorem for the three triangles. Okay, let's begin with this triangle. This triangle, from the problem we know this is perpendicular, so we have a right angle here, a right angle here. That's the reason we know this is a right triangle. Okay, so the opposite side is the hypotenuse. This B is the hypotenuse. So let's write the Pythagorean theorem for this triangle. It's B squared, the hypotenuse square, equal to the sum of the legs squared. So this is one leg, so it's 6 squared plus the other leg squared, and the other leg is 10 minus X squared. Okay, let's put this B. Now for this triangle. Okay, this is the right triangle, so the opposite one is the hypotenuse. So A squared is the addition of the legs squared. Okay, so one leg is 6, this is one leg, so one leg is 6 squared, and the other leg is X plus X squared. Okay, and now let's make the full triangle. Okay, the bigger one. This is the right angle, so the opposite angle is the hypotenuse 10. So we have 10 squared equal to the sum of the legs. So this is one leg and this is the other leg. So it's just A squared plus B squared. So we have three equations so far, and we are going to solve these equations for X. Okay, so this is B squared and this is E squared. We can substitute B squared here and E squared here. Yes? And after that, we will have an equation on X, because here A is in terms of X and here B is in terms of X. So after substituting the A and the B squared, we will have an equation in terms of X. So let's do it. Instead of this A squared, we will write this, and instead of the B squared, we will write this, because here we have B squared and A squared. Okay, just like here. So 10 squared is equal to, instead of the A, I will write all this, 6 squared plus X squared. So this is like the A squared, plus, instead of the B squared, I will write this. Okay, so this is like the B squared. Okay, and now let's simplify this. Okay, 10 squared equal to, we have 6 squared 2 times, so it's basically 2 times 6 squared. If you want to do it, just do it. This is 36 and this is 36, and you can add 36 plus 36, which is the same, guys. it's the same. I'm just lazy to do the operations, okay? And since this is the 6 squared 2 times, well, 2 times 6 squared, okay? Plus the x squared, and I am going to expand this binomial squared, okay? So you know this is the square of the previous one, double the product, and minus 20x plus x squared. You know how to expand this from algebra, okay? What is next? Well, we have these like terms, x squared and the x squared 2 times. So we have 10 squared equal 2 times the x squared plus minus 20x. So we, instead of the plus, I will write minus 20x plus 2 times the 6 squared, and this is term plus. Why I am doing this? I am reordering the equation in order to have the x squared, then the x, then the terms without x, you know, in descending writing, okay? The x squared, then the x, then the terms without x, okay? That's the reason I am like putting the terms in other sides, okay? So everything's fine. You can see the 10 squared here and the 10 squared here. So we will subtract 10 squared from both sides, and this will cancel out with this. Yes, they will cancel out because I can subtract 10 squared from both sides, and 10 squared minus 10 squared, well, of course, is 0, equal 2 times x squared minus 20x plus 2 times 6 squared, and this is no more, okay, because we subtracted. And you can see that we have a factor of 2, because here is 2 multiplying, here is 20 multiplying, and 20 is 2 multiplied by 10, and here is a 2 multiplying, so we have a factor of 2. So we divide by 2 all the, well, let's put it term by term, so you can see it more easily. And we have this new equation, 0 divided by 2 is 0, of course, and 2 by 2 this is square, and this is 20 divided by 2 is just 10x plus 2 divided by 2 is 6 squared. So instead of 6 squared, now I think it's a good time to write 36. So we have this equation, and this equation will tell us it's a quadratic equation, yes, and this equation will tell us the value of x. If we solve that equation, well, let's see what happened. Can you help me with this one? How can we solve this equation? I want to erase because I think I don't have more time, more space. Let me try this. I will solve it around here. X squared minus 10x equal to minus 36. Yes, I just this 36 put in the other side as minus 36, and I am turning the left right side and the right hand side. Okay, so now okay, sorry, now is, let's complete the square. It's the half of this squared, so it's plus 5 squared. Yes, the half squared and plus 25. 5 squared is 25. So this is x minus 5 squared. You can know this is the right expansion, the right factorization, because we have a perfect trinomial. And 26 plus 25, it is 5 and 6. It's minus 11, yes or no? Tell me, because I am bad at math. It's 5, then 6, yes. Minus 11, because this is bigger. It's greater. and then is x minus 5 equal to minus 11 root, and here we have a problem because this is the root of 11 imaginary. Since this step you can tell that x will be equal to 5 plus minus root of 11 imaginary. It's a complex number, so the solution is a complex number. We did everything right, and the solution is a complex number. This is a contradiction, okay? Because the side of a triangle cannot be complex. It cannot be negative, and it cannot be complex. It cannot be imaginary. So we reach a contradiction. This means this side of the length of 6 is not true, okay? Because due to this 6 we reach a contradiction. So or this is false or this is false, and we know this is true, so this one is the one that is false, and that means this construction is impossible. See you guys.